asking that all of the test team personnel switch to a common channel, which they will remain on through the balance of the count. The support operations are ready for launch and emergency aircraft and personnel on station.
Okay, flight crew, be advised you may get a klaxon here during the cabin leak check. Roger.
Pilot Dick Covey will be asked to set the switches in the cockpit to the pre-start position for the auxiliary power unit or APUs at the 6-minute point. T-minus 5 minutes and counting.
For orbiter APU start.
And BLT, perform the APU pre-start.
T-minus 15, 14,
13, 12, 11, 10. We're go for main engine start. 7, 6. We have main engine start. 3, 2, 1, 0. And liftoff. Liftoff. Americans return to space as Discovery clears the tower.
Roger, roll, Discovery.
Crew confirms roll program. Houston now controlling.
Our return to flight in September 1988 with the launch of STS-26 was a high point for the Space Shuttle program and for USBI as well. In that mission, and in the 8 since then, the performance of the solid rocket booster has been flawless. This performance was due to the excellence of our SRB team. Our ability to manufacture, assemble, test, launch, recover, and refurbish the SRB has been built on a foundation of highly reliable quality hardware, coupled with your technical and management expertise. Following the Challenger incident in January 1986, we embarked on an intensive recertification of the SRB. Through your efforts, we were able to verify our compliance with requirements and enhance the safety and reliability of the SRB in the process. Through it all, you showed that you truly understand the importance of our work. The SRB hardware represents our individual commitments to the safety of the Space Shuttle crew and the success of their mission. USBI has produced this video to show the complexity of the SRB task and to thank you for performing your part of that task so well. The SRB is 149-foot tall solid propellant rockets stacked in segments or assemblies. They supply the shuttle's primary liftoff thrust of 5 million pounds during the first 2 minutes of flight. Its main assemblies are USBI's aft skirt, Thiokol solid rocket motor, or SRM, and USBI's forward assembly. USBI integrates the SRM with the aft skirt and forward assembly to make up the SRB. The production cycle starts with receipt and inspection of new and refurbished hardware at our assembly and refurbishment facility at the Kennedy Space Center. Once the hardware is accepted, it is put into our production operations. The first assembly in each SRB stack, the aft skirt, is an aluminum structure that must support the entire shuttle weight of 4.5 million pounds. Hold-down posts in the aft skirts lock down the massive 185-foot tall shuttle on the mobile launch platform as it moves slowly to the launch pad. They also restrain the vehicle as it undergoes a variety of launch preparations, including main engine test. At the instant of liftoff, the hold-down posts release the straining shuttle vehicle on its mission to space. To protect the aft skirts from the searing heat during boost phase, we must apply a special insulation to all exterior surfaces. We also assemble and install a thrust vector control, or TVC system, in each aft skirt that steers the SRB exhaust nozzles in response to commands from the orbiter's flight computers. Steering is required to place the shuttle into the proper orientation for orbital insertion. Each TVC system consists of 2 hydraulic power units, each of which includes an auxiliary power unit and hydraulic pump, and hundreds of flex hoses and tubes. This equipment drives 2 precision servo actuators that move each motor nozzle for shuttle steering. As a final in-process check, we run tests on the aft skirt and TVC assembly in a special hot fire facility to assure proper response of the actuators in a full-up firing environment. Our other major structure in the SRB stack, the aerodynamically shaped forward assembly, tops off the motor segments with a forward skirt, a frustum, and a nose cap. The forward assembly houses most of the SRB's electronics and instrumentation, such as the integrated electronic assembly, which controls onboard electrical systems and distributes power, gyros for measuring vehicle rates, sensor timer unit for sequencing of recovery events, altitude switch for initiating parachute release at proper altitude, batteries for onboard power, flight camera for recording main parachute deployment, range safety antenna for receiving ground commands, integrated receiver decoder for processing those commands, distributor for routing power and commands, and couplers for transmitting RF signals. For final flight verification, we run tests on the forward and aft assemblies with our automatic booster assembly checkout system, which performs automatic diagnostic tests on all our flight systems. We're also responsible for all of the systems and components critical to the SRB separation and recovery events, such as attached rings and struts for mating to and separating from the external tank, booster separation motors for the aft skirt and forward assembly, which thrust the separated SRB safely away from the shuttle orbiter, and explosive transfer lines, manifolds, and ordnance rings for severing the nose cap and frustum. After the SRB is separated at about 28 miles altitude, they coast up to about 40 miles. Approximately 5 minutes after launch, they start to fall back to the ocean and enter the recovery stage of the flight. At 16,000 feet, an altitude sensor initiates the nose cap severance assembly and thrusters. The nose cap deploys an 11-foot diameter pilot parachute, which deploys a 54-foot drogue chute. The drogue provides initial deceleration and proper orientation of the SRB for main chute deployment. At 6,000 feet, the altitude sensor initiates separation of the frustum, which pulls the 3 main chutes from their deployment bags. These parachutes are some of the largest in the world, 136 feet in diameter, a size required to assure a soft water landing for the segmented SRB structure. Onboard cameras atop the SRB look straight up to photograph frustum separation and main chute deployment. The chutes deploy in stages to reduce SRB velocity incrementally and minimize stress on the chutes. Full deployment takes about 20 seconds. All parachutes are packed by USBI and designed for sequential deployment. We also provide the parachute separation hardware and the parachute floats. Under fully inflated chutes, the SRBs impact the ocean at more than 50 miles per hour. Once impact is sensed, parachutes and floats are released. Without this release, the suspension lines could become entangled. Without flotation, the chutes could sink and be lost. The frustum is the last to splash down under the drogue chute. Since the SRBs were designed to be reusable, they are recovered immediately after splashdown. with the SRB in spar or upright mode. The open nozzle end, 100 feet below the surface of the ocean, must be plugged so that the seawater can be pumped out by injecting air into the motor. This forces the SRB over into the log mode, a horizontal mode suitable for towing. The frustum and parachutes are also recovered. All SRB assemblies are returned for repair and refurbishment. We refurbish these assemblies in various facilities at the Kennedy Space Center. We perform post-flight evaluations in laboratories at our facility in Huntsville, Alabama. Our refurbishment effort involves a wide variety of manual processes, such as repairing, drying, and repacking the recovery parachutes, stripping and painting a multitude of parts and panels, and repairing the SRB structures. Refurbishment also requires some unique automated processes involving 4 30-foot gantry robots, which perform tasks in less than 10% of the time previously required by manual methods, and with far greater safety and precision. Automated tasks include removal of the multi-layered thermal protection coating and its reapplication using sophisticated robotic and image processing technologies. Some components may require refurbishment at a supplier's plant. These are removed from the recovered assemblies and packaged for shipment. Here we see the inside of the aft skirt and the TVC system and some of the effects of reentry heating. We hope this has given you a new perspective on the full circle of events that make up each shuttle SRB flight. Together, we at USBI have pioneered the development of the world's first reusable space booster, a proud accomplishment. As we prepare for each launch, we must do our best every time to continue the dedication to excellence that got us back to flight, remembering that our nation's pride flies on the quality of our work. The Space Shuttle, it flies on the wings of teamwork and pride. It leads us into the 21st century and our future in space.